Algebra 2 students. Today we got another exciting chapter in math for you. Chapter 2-4, the graph of y equal kx, which, as you already know, is the equation for direct variation. If y varies directly with x, then we know that the relationship is y equal to kx, where k is some constant called the constant of variation. So let's look at an example, and then we're going to graph it. So the distance you are from a lightning strike varies directly with the time it takes between seeing the light and hearing the thunder. So in other words, the longer that time takes from when you see the lightning bolt to hearing the thunder, then the farther away you are from the lightning. So that's the example of vary directly. The distance, let's call it d, and varies directly with the time. So call the time t, and we know the relationship is d equals kt, because we said it varies directly. That was from the earlier sections. Okay, I'm just going to give you the constant k. It's 1 over 5. We've done problems where we had to solve for it, but for this, I'm just going to go ahead and just give you the k. So let us look at a few points, and we are going to look at the graph and see if we can come up with any conclusions. So t is time in seconds in between seeing the lightning and hearing the thunder, like that thunder that was scaring all the IP4s, I think it was, on Wednesday. So let's look at if it took 5 seconds between seeing the lightning and hearing the thunder, then I am 1 mile away. And if I was 10 seconds, then 10 times 1 over 5 would be 2, and so on and so forth. I fill out these different pairs of times and distances. Now, if we were to graph this, our horizontal axis will be time, t, and our vertical axis will be the distance. So let's just graph some points. So we have the point 5, 1, 10, 2. I'm just creating my axis here. 10, 2, 15, 3, 24, and 25, 5, and 36. And I connect the dots, and sure enough, I get a line, which you probably expected when you saw the equation, because we know that d equal 1/5 t should be an equation of a line. And sure enough, it is a linear function. So direct variation is a linear function when it's like y equal to kx. Basically, x is to the power of 1. Then it's a line. Now we're going to review something called the slope of a line. Now, I'm sure you have run across this many times before in your math adventures, but we're going to review it again because it's such an important concept. The slope is going to be the steepness of the line, meaning the higher the slope, the steeper the line is going to be. And the way we calculate slope is you can get it by choosing any 2 points that you want on that line. So we'll call it x1, y1 and x2, y2. What we're going to do is we're going to look at the change in the vertical distance, so y2 minus y1, and we're going to divide it by the change in the horizontal distance, x2 minus x1. So I'm going to go ahead and write that out. The slope is equal to the change in the vertical distance over the change in the horizontal distance. Now, a lot of you guys probably remember this as change in vertical distance, my rise, how much I'm changing going up, and the change in the horizontal distance as the run, how much I'm changing moving horizontally. And so a quick way to remember slope is rise over run. I'm sure you've seen something like that before. And the formula is going to be the rise is the difference in the y coordinates, y2 minus y1, and the run is the difference in the x coordinates, x2 minus x1. So that's a pretty important relationship, you definitely want to keep that one in mind. It comes up on the SAT all over the place, by the way. Okay, and it comes up for future math that you might need to do. So definitely, that's why I highlighted it with a rainbow box, because it's that important. So let's look at an example. Let's find the slope of that direct variation equation that we've studied with the lightning and the thunder and the time between seeing that and the distance. So that was the distance equals 1/5 t. Now, you might already know the slope just by looking at the equation. And if you can, good for you. You are ahead of the game here. But let's figure it out anyways. So we're just going to do change in the output distance. Now I can choose any 2 points to figure this out. So I'm going to choose this point 15.3 and I'll choose this point 10.2. So I could pick any of the 2 points that I want to figure out the slope, but I'll just choose those for now. So I'm going to subtract the distances. So I'm going to do 3 minus 2 over the difference in the inputs. Remember, 3 went with 15. 3 went with 10, and 2 went with 5. So the change in time is 10 minus 5, and sure enough, I get 1/5. And you might be thinking, wait a minute, 1/5? That is the same as the constant of variation. And indeed, the slope of the line, you may remember y equal mx plus b, but that's what we have. We don't have any plus b, but that slope is right there, that number that's multiplied by our input variable, in this case, t. And we can recognize that relationship, and we're pretty excited about that. So here's me, and I realized that the slope is just that number in front of the input, and I'm so happy my hair is standing straight up. I am so excited about realizing that. And let's look at some different lines and the slope, so you can kind of get a feel of what slope, what each line, just roughly what the slope would be. So I'm going to give you 4 direct variation equations, and you can tell me which lines you think they go with. So here they are. We're going to start with y equal 2x, y equal 1/2 x, y equal negative 1/2 x, and y equal negative 2x. So pause and try and match those with the 4 lines that I drew. Right, so the steepest positive slope is going to be y equal 2x, and then the one that's not as steep has a lower slope, but it's still positive, so it's still going to be sloping upwards, so y equal 1/2 x. And the negative ones, those are like you're running downhill. It's kind of negative steepness. So negative steepness is basically, it's not hard to run up. In fact, it's easier to run down these lines. So if you have a negative slope, the line is going to be tilted downward. Okay, so let's connect all this together with a little theorem from your textbook. It says the graph of the direct variation function, y equal kx, is a line. We see that because we graphed one of these and we saw it was a line. And moreover, the slope of that line is k, the constant of variation.